Hi, my name is Dominique Dubic. My presentation will be in French, but the slides will be in English, so I will translate my slides. Okay, the virtual commissioning from pre-BIM to post-BIM, life outside BIM for construction. Just as a little summary, this is the BIM plan that had been planned in 2000. We're at phase 2, where we started implementing BIM, and we're starting to develop smart tools to be able to integrate BIM in other spheres other than construction, which is the facility management, and even in pre-BIM design and the preparation of a project. So, in the 1980s, we would speak of CAO. I was comparing this CAO to someone who didn't want to use fax, because when architects had to drop their pads, it's about the same as resisting the use of fax machines. But now with BIM, same thing. There's some resistance, but I think that we won't be able to stop the wave from coming through. I wanted to make my presentation on the difference between construction BIM and management BIM. These are two visions and two types of BIM. So if I look at the life of a project, as done here by a pattern, this is University of Montreal with a schedule, you can see the different steps. It's the vision. We can see the PFT at the beginning, or the FTP. In real life, the life cycle is a little black thing. The part of it will be project preparation, then the rest of the life will be after the operations. Now, BIM, therefore, is an asset management. If I look at the vision, where we start with the architect, we do the whole project, we come to the end, and then at the end we hand over a model for the owner to manage his facility. However, our clients do not have that kind of project. They've got a real estate portfolio with buildings that have paper plans, CAD plans, no plans, and BIM models that come through all that from time to time. So here we're starting from zero information to information that is close to the millimeter. So we often say that in real estate management, the E is more important than M. We need more. We need more information than modeling, is what he's trying to say. So comparison between the construction phase and the operation. What's important in construction phase? Well, interferences, clash detection, estimation, interoperability, energy planning. In the world of operations, we're talking risk, security management, space, portfolio management, equipment management, and energy management. So we've got really different concepts, and it takes different types of BIM to manage those. Now, in the case of construction, we do a lot of BIM for mechanical, electricity, architectural components, the different projects, characteristics of equipment. And then when we come to operations, well, we want to know everything that's collected upstream, downstream equipment, what switch, will I close that equipment there? We don't even want to know where the cables are. We want to know how it's connected, what it manages really. And the finishing, we don't want to know when we'll need to change the paint or the floor. We need to know what space is usable in real time and equipment inventory. So we're really in two different worlds, really, with regards to specific needs. Between fiction and reality, if I look at a perfect world, which Autodesk promises us with BIM, I simply want to draw a parallel with what we had as a perfect world in 1995 when we created the company, which was computerized sharing of information. And here we had squared problems. We went from 2D, and now we have cube problems, right? exponential 3 problems since we've gone to 3D reality. The idea really is to be able to work together and work through these things. What do we have as a present reality? Well, the pre-BIM, everything that is upstream of a project, people gather information left and right. They come up with Excel and PDF files. You come into the world of construction, they model everything in 3D, nice Revit models that end up on USB keys. And then we've got some post-BIM, people who need to manage the buildings, and they will re-enter the information in Maximo or whatever and try to enter that information for better management. Now, what do we try to do? Is to reconcile the different links of the chain so that the information from one step serves the other steps. It's for a continuous process. That's our challenge, as we set it for ourselves. And it's a challenge that will surely take a few years to materialize. Path towards a solution, we spoke of format, IFC and uniformat. We spoke of omni-class, sub-formats and IFC, of IFC and uniformat. So let's use standardized formats. That is a solution to be able to speak to each other. I could talk to you about IFC. Those who don't know the definition should learn it by heart. It is the exchange format in BIM. If I do it this way, BIM is what? Software, application, specific data, both digitally and graphic. And IFC is an exchange format. There's no file as such. It's just a standard among different platforms, universal data, and we have alphanumeric information only, okay, decoded by the computer, the software. And so BIM, not to be confused, it's more at the level of software. Uniformat compared to IFC, once again, you shouldn't throw out the baby with the bathwater. Uniformat for 20 years, since 1995, really, that we've been implementing it. There are still elements that are good in uniformat. Shouldn't throw everything out. I think the future is in the synchronization of these formats. In the case of uniformat, therefore, it's a good standard, which is basic, 5 very well-determined levels, very clear. In case of IFC, it's not perfect. The standard that was done through committees, engineers, sometimes there's some people, sometimes not. It gives a format that is a little asymmetrical. Certain sectors are more developed than others. I think we need to work to make it even more useful to all specialties.
If we talk about pre-BIM, how to incorporate BIM upstream? For BFT, what is important is to establish needs and then validate the project throughout the execution. Make sure the project was properly done at appropriate benchmarking and many comparative elements, and see what was planned and what was done. How to apply this to BIM, to create a database. So a database of all technical files to compare the models with what the users have approved. So levels of technical sheets. We have 3 levels of technical sheets. The generic one, generic for our organization as a whole. There's a specific one for the project that we're doing, and a particular technical sheet. For instance, here is a sheet, the generic for university professors in their office. If I go to an architecture school, the office will become the office of a professor. So I added, for all professors, a desk with a table for computers. And when I go to this particular sheet, there's Mr. Smith, who didn't want a computer, but he was 80 years old and wanted to keep his old equipment. So it's from the generic to the more specific, and we do the same thing with equipment. So this gives us databases for space and equipment. The project will be started, and we can start to estimate on the basis of a structured approach. If I compare with the design construction, there's a multiplication of models. We'll start having models that will be created on the design side that the professionals will do in their office. Ideally, everyone in the same office with a uniform mock-up. We cannot say one model fits all because the projects we've seen so far, the building is divided into sectors, and then it's cut again because everyone is working a bit on his own. And we divide all of this. There'll be 50, 60, 70 mock-ups. This is just at the design stage. The main contractor will be looking for the appropriate tool to use, and depending on market conditions and subcontractors, there'll be a new set of models that'll appear. It'll be construction mock-ups. So there's the commissioning of the building operations. So we will create a new mock-up. We can't go through all the details. There'd be too much. So we need a simplified mock-up. So there'll be a new set of models that will allow possibly one model for the whole. There'll be much less information, but the various functions that have to be done of managing spaces, of prevention, and so forth. So the idea of virtual commissioning, while people are building, others will take the information that was created by the design people to create a management model. So we'll start transmitting information for equipment, for services that are needed, phone services, computers. The moving will have to be planned. So the building is delivered eventually. To deliver it first virtually so that it can be implemented. So the advantages is to get information for maintenance cost, operation costs, human costs, phone system, and to be able to optimize the interoperability of the various systems that are being installed. And this brings us to the age of big data. So based on what we are producing, there'll be more and more databases. And then there's the internet of on objects, and we'll be receiving what I call big data or mega data. What is big data? I'll show you a few citations. Wikipedia. There's so much data that's so large that it's hard to operate under normal management conditions. So these are huge figures. So there's supposed to be an incredible amount of pieces of information. So what is the problem with big data? Finding the mistakes in all of the software that's being used. The update require a lot of time. We're delivering a building, but already it's changing. And as the users come in, there'll be changes made. So the update and the maintenance of all this data will be very complex. There's requests for reports, for graphics, for information of all kinds. Customers request more and more information on their building, so we have to generate ways of communicating the information that's generated. And then there's the problem of consulting one specific detail that we're looking for. So how to visualize big data? Here's what IBM thinks of it. This is Wikipedia as seen by IBM. The number of the frequency. We decided to do the same thing, but using a model and transforming 2D into 3D. I have a small video here that's due. So the example that I'll show here, it's cette fois CGEP. So we took a model. It's on Google Earth. So we're able to get the information that we know about various uses of space and of rooms. So we have here all the information that is managed on a daily basis. So I can go back to 2D, 3D. So what we did, we asked a group in Quebec who prepared a report on the maintenance of assets. They were produced, and various buildings were sorted. So we were able to visualize material life cycle based on various codes with a 3D model that can be opened and closed at will. So the communication between VFA and our system was done via uni format. So all of the data was compiled in uni format. So they can be prepared, modelized, and colored. And then I could visualize for year 1, year 2, year 3, year 4, just by moving the cursor. And this will bring us to another way of visualizing. It's an approach to using BIM. Why do we use Google Earth? Because it's much easier for a client to use Google Earth than other tools that are less user friendly. So the level of knowledge required to use the model is very high. This brings me to another way to visualize information. We realized that there was such information was so scattered. Geomatic statements. There was a problem in bringing together all of this data and to a scale that was manageable. We developed a new concept that's called voxels. So there are various units. 1/10 of a second represents 3 meters. So a voxel is a room 10 feet by 10 feet approximately that allows us to attribute values. So voxels to intercept data from all other systems and then show them in real time to get an estimate of what's happening in my building. So if I start at the equator, the advantage of the voxel is that it's a set place in time and in space. The voxel will always have the same name. So there's an element of permanence in the databases that allow us to follow various softwares. How does it work? To map the planet or buildings. So we use the paper that we already have, and eventually they're superimposed on the 3D mock-up, and we transfer it to the Earth using Google Earth, or it can be, we can use geomatic cards of the city of Montreal, and then we do the whole building after we can analyze in real time the information that's derived from this. For instance, the density, the heating, the air conditioning, so the voxel becomes a place where information is gathered from many systems, and the average gives us various colors. The same thing with weather data. So there are clouds in the building that allow us to analyze the big data that comes from all of the systems that are produced based on rivet mock-ups or plans that the client has provided us with. So with one building, we start with one building and then we spread it out to all of the buildings and then to all of planet Earth. So this is the kind of research that we have, applied research for the BIM, using BIM.